As you can see, this is the data given. So one is rainfall and another one is umbrella sold. And we're going to take the regression analysis of this and the regression statistics. So basically, what we see is the one variable is dependent on another. So when it comes to like rainfall, the more rainfall, say for example in Jan, the millimeters required was 82 and the plus was 15. So when it comes to Feb, when as rainfall increases, the number of umbrellas sold is 25. And using the statistics, the predictability, as you can see here, is 0.9171. And but in few cases, even when the rainfall is high, the umbrella sold will. There might be like various reasons for this because sometimes there might be a lag of stock. So what they can do is they can like make sure the stock is available at all times, especially when the rainfall millimeters are more in particular months. So they make sure they do not go on a loss. So this is umbrella sales. So next, let's go to prediction sales. So as you see here, we have like three data: sales, price, and advertising expenses. So first we see is like whether the price of the umbrella, whether it is dependent on this number of sales it does. So as we can see here, as we can the predictive thing that I got is 0.82 percentage, and as you can see here, when the prices are low, the sales are more. So this can prove that customers are willing to buy umbrellas at a very low price. And also the advertising expenses, what they can do is first, if they sell at a low price and if the sales are more, and if they spend a lot on advertisement, and also if they buy it in a low price, and if the customers are not willing to if the sales are very low, so what they can do is like see more, which is more efficient, like combining advertisement and setting the proper price so that they don't like lose out on profit. And as I told you before, the 82% and the rest 18% can be affected through maybe say market is maybe like the demand, maybe the weather conditions. So this is basically the prediction analysis that I use, and the data is already analyzed. So next, let's move to custom. So moving on to the churn risk. So let us move. So in churn risk, basically like there are three things where other customers, where since the last purchase frequently complain. So the churn, like customer churn is nothing but you see at what customers you risk at losing and what customers are more likely to come back and purchase more umbrellas from you. So as you can see here, the predictive thing that I got is 0.801 and multiple R is 0.89, which shows that the customer churn is completely based on the path data. So as you can see, let us take customer one as an example. So the since the last purchase was around 30 days and only frequency like level of purchasing is only 2 and complaints is 1. So he's at like risk. So this data basically we can easily calculate by using this customer churn, and we can easily find customers which are at risk or safe. As you can see here, the days since last purchase was 10 days and he has a higher frequency purchase and customer 1. So he's in safe. So what the company can do is while identifying these customer statuses, they can provide like additional discounts or maybe like personalized messages to the customers to make sure that they don't lose the customers, and also they make sure that they come back and frequently purchase the umbrellas. So this is the help of customer churn.